All right, let's look at chapter 12 now. Chapter 12 is on something called a simulation. Um, Simulation, you can, if you know what the word simulate means, you probably know what a simulation is. It's sort of an imitation um, of an experiment. Whenever I think of the word simulation, I think of when my family first we got our first family computer when I was like in middle school. My dad used to play a game called Flight Simulator. And it used to, like, he would literally have a joystick that he would hook up to the computer, and the screen looked like you were in a cockpit and you were flying a plane. It simulated, imitated flying out an airplane. So a simulation is, like I said, the imitation of chance behavior. It accurately reflects an actual experiment. So if performing the actual experiment is not feasible, you could do a simulation. Okay. Now, in a simulation, the trials have to be independent. Okay. So if you think of what the word independent means, okay, um, it kind of has the similar meaning in stats. So independent trials means that the results of one event has no effect or influence on the next. So the classic example is the flip of a coin. Okay, the result of the first flip of the coin is not going to affect the result of the second, the third, the fourth, so on and so forth. An example of dependent trials, the opposite would be like if I put all of your names in a hat and I picked out the first name and didn't put that name back in the hat. Okay, once I start picking names out without replacements, now I can't pick that name again. So that would be an example of a dependent trial. The other thing with the simulation is you want to repeat it many times. We've talked about this before. It's always good to have a bigger sample size than a smaller sample size because it decreases the chance of bias in your results. So it would be better to flip a coin 100 times than say 2 times. Okay. So there are many ways you could do a simulation. I know if you have a situation that's 50-50, you could do coin tosses. If you have a situation that has 6 possible outcomes, you could do a roll of a die. So on. So another way we do things is through random numbers or random digit generators. Um, you could even ask Siri for a random number, and it will literally give you a number, um, so on and so forth. The other thing they use are random digit tables. So I just wanted to give you an example of how we can use assigning digits. So we have choose a person at random from a group of which 70% are employed. One digit simulates one person. So here's an example of how we did that. Okay. So notice in our number system, we have 10 digits, 0 through 9. So in this case, I said let 0 through 6 represent employed because those are 70% of the possible digits, 1, 2, the 7 of the 10 digits. And then the last 3, the remaining 30%, would represent not employed. We could also divvy it up this way. I could say 1, 2, 3, 4, 5, 6, 7 represents employed, and 8, 9, and 0 represents unemployed. Same thing, 70% of the digits are employed, 30% of the digits are unemployed. Or I could go 2-digit numbers. I could say 01 to 70 represents employed, and 71 to 00 represents not employed. Okay? The point is, whether you use 1-digit, 2-digit, 3-digit numbers, as long as 70% of the possible combinations represents employed, 30% represents unemployed. That is an example. That would be a proper example of setting up a simulation. Okay. Here's another example. What if I changed it to choose one person at random from a group of which 73 people, 73% are employed? Okay. Well, 73%, in that case, I could only use two-digit numbers. So I could say let 00 to 72 represent employed and 73 to 99 represent unemployed. Okay. Obviously, that's not the only way I could do it, but there's several different ways I could do that, representing using two-digit numbers. I could use three-digit numbers if I wanted to. But the point is, out of the possible combinations here, 73% of them are represent employed, and then 27%, the remaining, represent non-employed. Okay. If I have multiple categories like I have here, I can do the same thing. So I have 50% employed, 20% unemployed, 30% not in the labor force. So I divvied it up this way. So 5 of the 10 digits, I used one-digit numbers. 0 through 4 was employed. 20% of the possible combinations represent unemployed. 30% represented not in the labor force. So that is how we could use random numbers to set up a simulation. So if I set it up this way, I could then go to Siri and ask Siri to give me a random number. And depending on which number comes up, that would represent employed, unemployed, or not in the labor force. Okay. Let's look at this fourth example. This one I actually stole from the textbook. And there's a similar question like this on your Math Excel assignment for this chapter. This is a really short chapter in case you can't tell. But let's take a look at this. An elementary school teacher with 25 students plans to have each of them make a poster about 2 different states. The teacher first numbers the states in alphabetical order from 0, 1 to 50. So notice he or she uses uses two-digit numbers because there are 50 states. Then uses a random number table to decide which states each student gets. Here are the table of random digits. Okay. We want to know what 2 states does the first student get, and what 2 states does the second student get. So again, because we're talking about states and there are 50 states, we're going to use two-digit numbers. We're going to go 2 digits at a time. So watch what I do here. So if I look at the first 2 digits, the first 2 digits are 45. So that means the first student's going to get whatever state number 45 is. Okay, if I look at the second 2 digits, that's 92. But what's the problem with that? There are only 50 states. So 92 is too high, so I can't use that. Look at the next 2 digits, I have 10. Okay, that is a possible state number. So that means the first student is going to make a poster about states number 45 and state number 10. Okay, and I could continue from there for the second student. So the next 2 digits are 17. That works. The next 2 digits are 10. Now that would normally work, but what's the problem with that? Well, the first student already took state number 10, so we can't use that again. And then we have 22. So that means the second student is going to do a poster about state number 17 and state number 22. Okay? And we could continue doing this until we got to all 25 students. Now, obviously, if we were going to do this for all 25 students, we would have to use a longer list of digits. in order to do that, but you can see how it works. Okay? That is really it for chapter 12. Like I said, it's a really short chapter. I do want to take the chance and go through the remaining 4 questions on the Math Excel assignment 9, 10, 11, and 12. Questions 9 through 12 on the 10 through 12 assignment come from chapter 12. So again, as always, as I said in the previous 2 chapters, my suggestion would be pause the video right here, do the last 4 questions on the chapter 10 through 12 assignment, and then come back and watch me go over these. So let's look at number 9. A study found that out of every 1,000 babies born in country A, 2 have some kind of major birth defect. How would you assign random numbers to conduct a simulation based on this statistic? So the key is 2 out of every 1,000. 2 out of every 1,000. So 2 out of every 1,000 implies we want to use 3-digit numbers. That takes out A and B. So the question is 2 out of every 1,000. So out of the 1,000 possible combinations, and they go from 000 to 999, which one represents 2 out of 1,000? 0 to 1 or 0 to 2? It's actually 0 to 1. 000 to 001, that's 2. And then the rest would be no major birth defect. So the answer for this one should be C. Okay. Number 10, we're going to do the same thing I did in the PowerPoint. We're doing the thing with the states. So these are our numbers. Which 2 states does the first student get? So we look at 2 digits at a time. So I have 35. That works. Okay. The next one is 61. Okay, that's not going to work because that's too high. So we keep going. The next one is 22. Okay. The first student gets 35 and 22. Okay, and if we continue from there, next we have what? Let's see. 42. That works. Okay. 42. Then we have 22. We can't use that again. So then we have 48. 48. So 42 and 48. And that's it. So it's just a repeat of what we did in that example in the PowerPoint. Number 11, the names of the 20 students in an English class are given in the accompanying list. The teacher will assign a group of 4 students to prepare a class presentation on poets. Use the random numbers below. Choose any 4 students for this project. So here's our list of students. Notice there are 20 students, so we're going to go 2 digits at a time. So our first 2 digits are 0, 5. 0, 5, so that's Kong is the first student. So that takes out D and B, brings us down to A or C. After 5, we have 32. That's too high. After that, we have 84. That's also too high. Then we have 03, which is Grub. That doesn't help us. Next, we have 11, which is Burbank. So that would be C. We don't even have to check the last one because that's the only one that has Kong, Grub, and Burbank. So the answer is C. We can stop right there. Okay. And let's look at the last one. An amusement park has opened a new roller coaster. It is so popular that people are waiting up to 3 hours for a 2-minute ride. Concerned about how many people who might be willing to wait in line for 3 hours feel about this. They survey every 15th female as they exit the park, starting from a randomly selected female. Okay, so this actually, even though Math Excel says it's a chapter 12 question, this actually goes back to chapter 10. So if you think back to chapter 10, selecting every 15th female, that is a system. That is a classic example of a systematic sample. Okay, the tricky one is B. Is the sample likely to be representative of people in line for the roller coaster? Okay, now look at the end here. They survey every 15th female as they exit the park. Okay, as they exit the park. Is everybody who goes to the amusement park, is everyone going to actually go on the roller coaster? My guess would be no. Okay. I like to go to amusement parks, but I can't stand roller coasters. So if they survey me, my result's not going to help. So surveying every 15 female as they exit the park is not going to be representative of people in line for the roller coaster, because not everyone exiting the park is going to have gone on the roller coaster. So the answer to that is no. Okay. And that is it for chapter 12. I wasn't lying when I said it was a short chapter.